Now, welcome back, guys. We're going to do some work on multiplying small numbers out of the textbook. I just want to make this quick video and talk to you about a couple of things. When we're multiplying numbers, we don't say we're getting the product of 6 and 3. We say 6 times 3. So these are specific words that are being used as instructions in your textbook. So you need to learn those things and look out for them. Now, there's other things going on here. There'll be a little bit of discussion about the associative law and the commutative law. They're things I imagine that when you're doing your mental multiplication, you're already thinking about these things and doing these things, but you haven't put a label on what you're doing. So we'll do a little bit of work on that. We will work on the algorithm as well, and we'll do some questions, and I'll outline the algorithm for multiplying small numbers for you. I completely understand if you're good at maths, you might be accessing a lot of the answers just purely through memory, and your knowledge of the times tables. So that's one mental strategy. I want to also play around with other ways of working. Okay, they're labeled as mental strategies in the textbook, but I really want to bring them out on paper and make them visible so we can have some really good discussion about different ways to work out how we multiply numbers. So I can think probably of about 6 or 8 different ways to do this. So let's get started and see where we get to. Okay. Let's have a look at multiplying. Let's start off with some smaller numbers, and I've written up on the board multiply and product, and in our question here I've actually used the product of 23 and 4. Okay, just to reinforce that concept of we've got words that we use every day that we often speak with, but we might see some instruction written down as a product of. So I wrote down flexible thinking. I was thinking about all the mental strategies that we can use, and we've got an algorithm, a set way of doing things, and we can play around with both those things. And I've just written some other stuff just on the edge of the board here about the associative law. It's about the order that we multiply in. We'll look at this in a moment, and what it's saying is it doesn't really matter if we go 23 times 4. That's going to be equal to 4 times 23, and we'll work out what that's equal to in a minute. Doesn't really matter. So that's important. That's handy to know when we're multiplying numbers. And the other law is it's a little bit tricky. These letters just represent any number. They're probably best to think about them as different numbers. And let's make something up. Let's do this. 2 times 3 times 4. Well, that's going to be the same thing as 2 times, let's try and keep the numbers underneath the letters for reference, and let's just double check what that's equal to. 2 times 3 is 6 times the 4. Well, that's equal, this side, the left hand side is equal to 24, and the right hand side, let's do the work in the brackets first. That's 3 times 4 is 12, and then we're timesing it by 2, and so the right hand side is equal to 24 as well. So it all checks out, it all works, and that's something to think about as we do the work. So let's have a look at this and work this out. Why don't we use the algorithm first, and we need to set this up as 23 times 4, and see how I've just tried to keep everything in a line here. 3 times 4 is 12. So I'm going to put the 2 down, and I'm going to carry the 1 and put it up here. Okay, this is the way we do the algorithm. Remember, it's a set way of doing things. So for 2 times, we're in the tens column here, 2 times 4 is 8. Let's add the 1 there, so that's 92. Okay, now we could do this as partial sums, and that looks a little slightly different, right? We can go 4 times 3 is 12, and then we can drop down underneath it here and do this as 2 times 4, well, 2 times 4 is 8, but that's actually 80. So maybe if you're doing it this method, you need to remember to line things up, and you've got to put another 0 in there. But it's quite okay if you're not used to carrying, it gets you out of jail. Now, we want more flexible ways of thinking about how we're going to work this product out, the product of 23 times 4. So perhaps we could do it this way. Perhaps we could actually do it as 20 times 4 plus 3 times 4. And let's check out how that works. That's 80 plus 12, and that gets us to 96 as well. 92, sorry. So there was a more flexible way to work. I've got one more, and that relies on a new law here called the distributive law. And this is kind of useful because it's the same thing as above, just set out differently. I'm thinking about 23 is 20 plus 3. And what I'm doing, I'm just changing the color of my pen so you can see. I'm multiplying the 4 through here. And so that's 4 times 20 is 80. 4 times 3 is 12. And so we end up in the same spot. So we've got all these different ways of working, and you know, I've actually got while we're talking, I've got another way. I've kind of run out of board, but a really flexible way. I'm thinking about 25 times 4, because that's nice and easy. That's 100, and make a little bit of adjustment. So 25 is 2 more than 23. So let's subtract 4 lots of 2 here. So that's going to be 100. Subtract the 8 and we get to 92 as well. So I hope you really understand what I'm saying about being flexible with your thinking. Just watch the question and see what they're asking you to do. Now, just to round out this video, I've got a couple more questions that I want to work through and talk through at the same time. Now, if I said to you the product of 7 and 6, you might have got thrown. But if I said to you 7 times 6, a lot of you might have just thought, oh yeah, that's 42. And get that from the memory banks, okay? Because you spent a lot of time in primary school working on those things. So if that didn't come to you naturally, there's sort of little landmarks that I remember. Often times 5 is something that's easy for me to remember because it's sort of the halfway point. So 7 times 5 is 35. And to get to 7 times 6, I just need to add another 7 to that. And away I go, I've got 42. All right, so that might be helpful. And the key here is that multiplication is just repeated addition. It's a bit, takes a while to write all this stuff out, and then I double check that is actually 7 lots of 6. it's easier to just write 7 times 6. Okay, so that's where it comes from, but there's a little tip there to help you out in this situation. So we can set up an algorithm here if you like. That's 9, and then we've got 1 times 3 is 39. So that was easy. Probably the algorithm was the easiest one to do that. Or we could have doubled it. We could have got to 26, add another 13, and we would have been at 39. So they're the flexible strategies versus the algorithm. This kind of question lends itself to the algorithm. And let's check this out. 9 times 4 is 36. We need to carry 3 there. And then we need to work on this. 2 times 4 is 8. 8, add 3, and we are at 116. Okay, so there was a lot of carrying there. It might have been easier to use a mental strategy like this. 29 is really close to 30. So that's going to be 120. And then we need to make a little bit of adjustment. And that adjustment was 4 times 1 and subtract 4, and we're at 116. So I'm just really encouraging you to use the algorithm, get good at it. But I also know that at times, if we see something, we've got an equally valid way of doing the mathematics.